Hello and welcome to Beginners Python and Machine Learning. My name is Tim Cummings. Every week we try to present a session on Python and all machine learning to help people who are new to the technology, and it's a good way of getting started. We used to provide all these sessions in person. Now we're doing a lot online since COVID. But we also do have some sessions in person about once every 5 weeks. We do them at the Brisbane Business Hub. So last week was at the Brisbane Business Hub, and we did a session, both Arun and I presented. And because the people who only watch online missed out, I'm just going to repeat my session from last week here tonight. So it'll be a shortish session. But the main benefit of these sessions is because we're streaming it live, you can ask questions. And so you can ask questions over the YouTube chat channel. I'll be watching this live chat. That's reasonably good. Sometimes if you put URLs in there, they get censored by YouTube. So the more reliable way of sending messages is through Slack. And if you look down at the bottom, the comment below this YouTube video, you'll see instructions on how to get a Slack account so that you can connect to this channel and ask questions. So learning to code inside Beginners Python is the one that you'll be using. So please ask questions, and the questions don't have to be exactly on the topic. We're really just trying to learn Python and the techniques here. By looking at different topics each week, we can sometimes initiate questions on other things that we happen to be doing at the same time. All right. Now, if you're on the YouTube link, which you must be because you're watching me, down below that you'll see a link to a Colab notebook. And so we'll be using Colab, Google Colab tonight, and that will allow us to do some of these exercises without even needing to be logged in. So if you click on the link, I'm going to click on the one here from Meetup because it's a bit hard for me to see the video as I'm recording it, and that will open you up in Google Colab, and it'll give us a notebook that we can use. Let's try. I might make it a bit bigger. Yeah. All right, so a notebook is just a bunch of cells. You can see I'm just selecting cells here, and in each cell you can have some text, like in these cells here, or you can have Python code, like in these cells here. Now, the first thing you're going to want to do is copy it to your own drive, and that way you can make changes and save your changes, and so you'll keep a copy of it. You'll always be able to come back to this link if you want to get the refreshed, or just the clean notebook that we started with today. So click on Copy to Drive. That's the button there, and that will create a copy and open it up in a new tab. And you can tell that you're working in a copy because it'll have the have the words copy of and the meetup name just here. So first thing you can do, click on connect. That'll just speed things up a bit. So as soon as, if you don't click on connect, Google will just wait until it sees that you're doing something that needs it to do some work, and then it'll start the connecting process. And what it's doing is setting up a virtual computer somewhere else, running Ubuntu Linux and Python, and it'll be Python installed with all the libraries that you normally get with Anaconda. Okay, so now you can see how much RAM and disk has been allocated to this virtual computer that we are using. Alright, so like I say, 3rd of May was when we presented this at Brisbane Business Hub, and so tonight we'll just go through it again. So it's an introduction to machine learning, So first of all, I thought I'd go through some of the terms that people use in machine learning. So artificial intelligence is really the broadest description of this technology. So it's the science and engineering of making intelligent machines, especially intelligent computer programs. Now, a subset of artificial intelligence is machine learning. So that's the branch of artificial intelligence which focuses on the use of data and algorithms to imitate the way humans learn. And so as it learns, as the computer learns, its accuracy will keep improving. And so that's an important feature of machine learning. Now, one way of achieving machine learning is to implement neural networks. So what a neural network, it's just an artificial neural network mimics the human brain through a set of algorithms, and it does that by a network is just a combination of neurons. These are artificial neurons, and the premise is that each neuron is capable of just a simple formula, just a linear equation. It looks at some data around it, like x1, x2, and x3, and then it multiplies each one of those by a constant, w1, w2, w3, then adds a bias to that, and that gives you an output. So this is like your standard linear equation. Remember that your constant is just your slope of your line versus that variable, and the bias is just your y-intercept. So I shouldn't have double-clicked on that. Right, so that's what each one neuron does, and then you can put lots of neurons together and make a level, and then each level, then you put the neurons into layers, and any neural network with more than 3 layers is considered a deep learning neural network. So deep learning is a subset of all neural networks, which is a subset of machine learning, which is a subset of artificial intelligence. So you might hear about people talking about using GPUs when they're doing deep learning, and that's because GPUs, which are graphical processing units, are very good at thousands of parallel simple calculations happening at the same time, and they can speed up the deep learning many times. Hours can come down to minutes. And even in Google Colab, in your runtime, you can change your runtime type if you want to include a graphical processing unit. Now, we're not going to be doing any deep learning tonight, so we don't need the graphical processing unit here. But if you are, then that's how you can achieve some good performance improvements. Alright, so now we'll introduce you a bit to Python. This cell here is called a code cell, as this one here was called a text cell, and you can create new cells. If I just hover in between those two, you can see I can add in another code cell or add in another text cell. So I can add in a code cell like this, and I can type in a line of Python like a equals 5, and then another line I can say, tell me what the value of a is. Alright, so I'll do this like that, and now I can run this cell. See, there's a play button here. I can run it, or you can see there's a keyboard shortcut of Control Enter, and that'll store the value 5 into the variable a, and then print whatever's in a. Now I'm doing this in this copy notebook myself. If you want, I'll give you the link for that one as well, and so you can just refresh that if you need and get all the latest things that I've been typing. Anyone with the link? So I'll paste that into the chat, and hopefully that won't get censored. and I'll paste it into Slack as well. Alright, so in this cell here I've got 3 variables, W1, bias and X1, that I'm just going to store some numbers in them. And then I'm going to calculate a very simple linear equation, a value, and store the result in Y. So Y equals W1 times X1 plus bias, and then I want to have a look at the value of Y. Now, because I'm using a notebook, which is it's a form of Python called IPython for interactive Python, I don't even have to say print Y, I can just say Y and it will display the result for me. So whatever's in the last line of a cell, the result of that will be displayed. So here we go, 17. It's worked out 7 times 2 is 14, plus 3 is 17. The values are remembered as we go from cell to cell. So if I put another cell in here and said, tell me what the value of A is, it says it's 5. It still remembers that A is 5, and so it will just use that value in any equations that need the value A. I can also define functions, and those functions are remembered from cell to cell. So let's create a function called myAlgorithm, which does pretty much the same formula, and then call the function using the value of 3 for X. And to call a function, you do the function name, myAlgorithm, and then you have these parentheses, and you put in the arguments into the parentheses that it will pass through to the function. So myAlgorithm with X equals 3 will return 24 as the answer, and I could do the same, call the same function again for X equals 4, and it tells me the answer is 31. Right, now in Python, it comes with some standard libraries and some third-party libraries if you've installed them. So you have to install the third-party libraries yourself, but in Google Colab, all the third-party libraries that normally come with Anaconda we'll get here in Google Colab as well. And one of those is the PyTorch libraries, which is some machine learning libraries provided by Facebook. There's also TensorFlow, which is some machine learning libraries provided by Google. But these days PyTorch seems to be the more popular one and more successful in machine learning competitions and things, so that's the one we'll be concentrating on. Now Torch Vision is one of those libraries inside PyTorch, so all we have to say is from Torch Vision import what we want to do, and we want to import models. And what this gives us is access to a whole bunch of pre-trained models that have been trained on other computers, and we're going to use one called resnet 50. Resnet 50, there were over 1 million images that were taken and classified into 1,000 different classes, and so those images were run through a training routine that would look at the image and work out these parameters, these W1s, 2s, 3s for each of the layers in our deep learning network, and it's going to have 50 layers. That's what the 50 means in ResNet 50. Well, that's the ResNet 50 there. And so it's going to use, I'm going to grab this model out of the models, and I'm going to use the weights that came from that training, and by specifying models.resnet50 weights.default, it'll use the latest version of those weights. So if it's been trained a bit more, I'll get those weights, and so whatever the latest is, and so hopefully that'll give us the most accurate way of using this model to identify new images. Alright, so we'll grab the model. I'll store it in a variable called myResnet50. It's 97 megabytes of download from PyTorch, and it's stored it in this Google's Ubuntu virtual server. So it'll disappear when we quit this session, So you'd have to run this again next time you open this notebook so that it will download it again. Now the first thing we want to do is tell it that we want to start evaluating existing images using this pre-trained model. So we have to run the eval function on that, so we've done that. So now it's ready to start. So the first thing we need to do is find an image. So I've gone to the ABC News site and I've found this news story here. It's about a Pomeranian rescued from the jaws of a 3.5 meter python at a Noosa dog beach. So there's the picture of the python, and so I've grabbed the URL from here. So copy image address, that gives me the URL. Now you might want to choose a different URL. If so, just come into the code here. There's the URL that I've just copied, and I put it into, I'm storing it in a variable called URL snake. You can put something else in there. It doesn't have to be a snake. I've just called the variable URL snake, but even if it's something else, this code should still work. So what we're going to do, we're going to use this library here, which is one of the standard libraries with Python, and to grab the image that's at that site and save a local copy of it. And local copies get stored over here in this file. So if you look in Google Colab, you'll see the files icon here, and there's a list of files that it starts with. Nothing there except a folder called sample data. So let's run this and see what happens. Then it's going to open this file that's going to have appeared over here on the left. Let's refresh. There we go, snake.jpg. So it's created that file by downloading it from this website, and then it's opened it using this image library, Python image library, PIL, and displayed it in our Jupyter notebook just by saying high-res snake. And there's the picture of the snake. That's the full picture. You can see the one in the news story actually cropped it, but the full image had a bit more to it. All right, now what we're trying to do here is use the machine learning model, the ResNet 50, to identify what this is a picture of. So what we have to do is get the picture into the same format that all the images that were learnt on were in. So what we're going to do, we're going to grab these transforms, and PyTorch gives us a library called transforms, or a module called transforms, which allows us to set up what we need to do. So what we're going to do is we're going to resize the image to 256 by 256. Then we're going to do a center crop of that to the 224 by 224 bits. Then we're going to convert it to a tensor. So a tensor is like a so you have a vector is a one-dimensional group of numbers, a matrix is a two-dimensional group of numbers, and a tensor is a three-dimensional group of numbers, or it can be more dimensions than that. So anything three or more is going to be called a tensor. So we need to convert it to a tensor because that's the format that is required for doing these evaluations. And a lot of machine learning is making sure your data is in the right format. So that's why we're going through these ways of converting the data to the right format. Then we're going to normalize the image. So each image is made up of a whole lot of each pixel in an image is made up of a red value, a green value, and a blue value, and each of those is a number between 0 and 255, just to say how much red is in each pixel, how much green is in each pixel, and how much blue is in each pixel. So the mean of all the red and greens and blues for the images in the source for the training of this model had a mean of 0.485 for red, 0.456 for green, 0.406 for blues, and the standard deviation was 0.229 for reds, 0.224 for greens, and 0.225 for blues. And I've given you a bit of a link here which runs you through explaining where these numbers came from. We could have calculated them ourselves, but we'd have to go through the million images that we used to train the model. So it's just easier to, someone else has calculated, they're not going to change, so we'll just use the numbers that they've used. Alright, so they're the steps to transform our image. So we'll put them into a variable called transform, which is going to compose all these transforms into one. And then we're going to take our high resolution snake and convert it into a low resolution 224 by 224 bits using this transform that we've set up. And by setting it up like this, if we had a lot of images, we could just do each one by one. Then we're going to use this unsqueeze function, which just really gets it into the right format for what we need. And I'll show you what it does. So once I've unsqueezed this snake, you see this snake 224 is as a shape of 3 by 224 by 224. So that's really 3 colors by 224 pixels wide by 224 pixels high. And by unsqueezing it, it just adds one more dimension and says there's a 1 there, and that 1 is basically saying we've got one image. It's 3 colors, pixels wide and pixels high. And that's why I've called it a batch, because you can have more than one image that's here, and you can pass a whole batch of images in to all be identified at once, but we're just going to be doing one. Okay, so we've run that. Okay, so now we pass our batch unknowns into our model and say, tell us what the what the class is of this this image. And it goes, all right, I'm going to give you the results. The results is 1 by 1,000 numbers. So your one image, we're going to give you 1,000 numbers to tell you what it is. and here's the first 10 of them. You know, minus 0.1754. Second one's 0.0016, then minus 0.16, minus 0.24. So how do we interpret those numbers? What they are, remember I said that this model classified everything into 1,000 different classes. Well, this is basically giving a score for how well it links to each class. But we need to know what those classes are, and for some reason PyTorch decided not to actually tell us what the class names are of all these classes. They've just given us numbers. There's class 0, class 1, class 2, class 3, class 4, class 5, class 6, up to 10. So I searched around, and this site here, gives you a list of all the classes that they used when they were developing the ResNet model. So let's open that and have a look. So these are the classes: tench, goldfish, great white shark, tiger shark, hammerhead, electric ray, stingray, cock, hen, ostrich, brambling, goldfinch, housefinch, and so on. So they are the first 10, and we got a score for each one of those. And you can see these scores are just numbers all over the place. They could be negative, they could be positive. I don't know what range they're in. So what I want to do is I want to get those class names and put them into a variable called list class names. So I've written just a few lines of code here, and this is using a library called Beautiful Soup to do some web scraping. Now I'm not going to go into the details of web scraping, but if you are interested in that, we've got we did a whole meetup on this, number 133, and there's a link. You can go there, and it'll give you details for a let's just go there. It gives you details to the YouTube link. It gives you details of a Google Colab notebook that you can use, or you can actually download this script and run this. This is a Python script, which is slightly different to a notebook, but it does the same thing as the notebook. So you can just run that straight on your computer if you've got Python on your computer, or you can go to the Google Colab notebook. All right, so let's run it, and then display. This is going to display the first 10 in our list of class names, and that just checks that it's done the web scraping properly. And we can see here tench, goldfish, great white shark, tiger shark, hammerhead, electric ray. So if you remember, they're the same names that we got before. And now we can link. We can say tench, whatever that is, gave a score of -0.1754. Goldfish had a score of 0.0016. Great white shark gave a score of -0.16. And so the higher the number here, the more likely it is to be the correct class. So what we're going to do is convert all these numbers into a probability. So we want to run a function over these so that it adds them all up and then gives us a range between 0 and 1 for each one, such that when you add up all of these ones, it will add up to 1. So the probability is 1 that it's got to be one of those classes, and which is what we're really specifying. We just want to say, given these 1,000 classes, what's the probability that this is the most likely class. The class that we're looking for, which is Australian Python, is not going to be in the classes, but we'll see what they've got as the best fit. Okay, and so softmax is the function that converts all those random, well, not random, but those numbers all over the place into a probability, so that they will all sum up to 1, and they'll all be scaled between 0 and 1. So let's run that. There we go. So the answer was the most likely class is class 62. It had a probability of 36%, and it's called a rock python rock snake. So our model's done quite a good job. It's come up as a rock python, even though it's a slightly different sort of python, but it didn't have our sort of python in the list. We could have what people do with these models is they actually fine-tune the training, and they start adding in more pictures of other animals and increase the number of classes, and that way we can include our Python in with rock Python, and then it would more likely get a higher probability that ours when it does the identification. But we haven't done that, and that's a topic for another day. So at the moment, rock Python is a pretty good guess. So let's have a look at. We'll sort all the results, and we'll just use the PyTorch function to sort, and find out which of the other classes it could have been if it wasn't actually a rock Python. So we'll look through the best guesses, and we're just going to be looking for the top 10. And so rock Python was at the top with 36%. The second best guess was 5%. It could be a night snake. At 2.5%, it could be a hog-nosed snake. So it's done pretty well. It knows, it's pretty sure it's a snake. King snake, boa constrictor, horned rattlesnake, horned viper, water snake, diamondback rattlesnake, sea snake. So we're down to something with only a 0.1% probability of it being a sea snake, but it still thinks it's a snake. So that got higher probability than all the other 990 classifications that were in the list. So that's the end of what we're planning to learn tonight. I hope you learned something from it. This is what we did in our session last week, where we had over 50 people turned up. There's the picture of the session, and Arun, who is presenting second. Next week he'll be going through. He'll provide another Google Colab notebook, and I believe he's even updated it from the one during the session we used last week, so it'll be even easier to run. And what he's planning to do is show you how to use ChatGPT to interpret customer reviews. So we have to provide extra data to ChatGPT. So for example, ChatGPT hasn't got access to any data after September 2021. But if you've got access to that data, you can give it to ChatGPT and it will update its results and use that extra data to have a more a fuller results and answers. So he'll be reviewing things like customer reviews of products like the iPhone 13, which didn't exist in September 2021. At the bottom here, I've got a few references. So if you're not a member of Beginners Python and Machine Learning, please join up. We've got over 1,600 members at the moment, and the top Python meetup group in Brisbane's only on about 1,700, so we're soon to become the top Python group in Brisbane. You can see all the sessions, our past sessions. We've got them on GitHub, well, my ones anyway. So in this online folder, you can see the meetup number, and we've either got notebooks like from Jupyter, Google Colab notebooks, or just straight Python scripts that end in .py. So the notebooks end in .ipynb, and they're all on various different topics. So you can find the one that you're interested in, and there's also YouTube videos to go with it, along with all these online sessions in this folder. So I hope you enjoyed tonight's session. I haven't got any more questions. I haven't got any questions coming up, so nothing for me to answer here, but you feel free to add questions to Slack after the session, and someone will probably read it and answer it for you, even though our video has stopped. Okay, our next in-person session will be on the 14th of June, Wednesday the 14th of June at Brisbane Business Hub. So I'll create a meetup event for that soon, and then there'll be another one in July. July will be about the 19th, I think. The 17th. No, July. The 19th of July. Yep. Okay, thanks for listening.